Hey, good day, everybody, and we are back again together. All right, we are looking at the Mpumalanga paper that was written in the recent prelims, just as a way of just revising. All right, so first of all, if you haven't subscribed, please become part of the family. All right, we want to grow this family to be as big as possible. Hey, they can't ignore us anymore. Hey, right. So, for those of you who need assistance with mathematics or physical science, please don't forget to just touch that dial. Okay, so you can actually send us an email at info@mlungisi.nkosi.co.za. All right, so we're looking at question 3 from the Mpumalanga paper, and this was based on vertical projectile motion, right? So first of all, they tell us that a 600-gram ball is projected vertically upwards from the ground. It reaches a maximum height of 20 meters above the ground. So there it is there. So the maximum height it reaches is 20 meters above the ground. They say on its way down, it lands on the roof of a 13-meter high building. Ignore the effects of air resistance. Now, very important for that statement to be mentioned, because that is what tells us that we are only moving under the influence of gravitational force, right? Now, let's look at the first question. They say write down the magnitude and direction of the acceleration of the ball at point X. Now, please, ladies and gents, I want you to note, whenever we treat questions that have to do with projectile motion, vertical projectile motion, I want you to remember that at any point of the motion of the ball, right, as it was moving upwards, okay, at any given point, whether be it immediately when it was released, right up until just before it lands on the roof of the building, at any given point, there's only one force. So if they say to you, draw the free body diagram showing all forces. So the only force that is acting is gravitational force, which is acting vertically downwards. So even at the point when this ball was stationary, gravity was still acting, pulling it vertically downwards. Okay, so at any point of the motion, there is only one force, and that is gravitational force. Now, of course, if gravitational force is acting, it means that the value of our acceleration at any given point, even when it was stationary, velocity is 0, but acceleration, now please note, means that the acceleration would be 9.8 meters per second squared. And in which direction is that? It is actually downwards. Okay, so it's in the downward direction. All right, so simply put, that's the answer to 3.1. So now we're looking for 3.2. They say to you, calculate the magnitude of the velocity with which the ball is projected upwards. All right, so first of all, what do we know? So I'm going to actually label the points, if you don't mind. Okay, I'm going to use that drawing over there. So this is the moment we released it from the ground. Okay, so I want to know at what speed did we release it from the ground. Okay, but what information do you know? Let's call this point A. Let's call this position B when it reached its maximum height. Let's call this position C when it landed on the roof of the house, okay, of the building. Okay, so this is A when it left the ground. Now, in order for me to answer this question, I'm going to have to choose, where do I choose to work from? Okay, I'm going to take A to B because I think I might have more information there. Okay, of course, this is solely up to you. Let me take information between A to B. Now, let's check. All right, what is my initial velocity? It means that I'm taking A as my starting point. I'm taking B as my endpoint, right? So what is my initial velocity? What's the velocity at A? That's the one I'm looking for, right? And then, do I know what my final velocity is? And remember, what is my final point? I've chosen B to be my final point, right? So in this case, what's the velocity at point B? This is when we reach maximum height, and at maximum height, our velocity. Remember, this guy will stop momentarily. Oh, by the way, there's something that I almost forgot. Okay, let's choose a direction, a positive direction. Let me choose upwards as my direction of choice. Okay, I'm gonna take upwards as my direction. So that means if I'm going to take gravitational acceleration, okay, right, in this case it means that the value of gravitational acceleration would be negative. Okay, now remember, in this case, at any given point, gravity is pulling this guy downwards, so it's accelerating downwards at a rate of 9.8 meters per second squared. All right, and we do not know the time that it takes to reach that height, that maximum height, but we do know that it was displaced 20 meters. Remember, they told us that it was displaced 20 meters, okay, to that maximum height. So we know that upwards is taken as positive, so it will be a positive 20 meters. Please remember that displacement is a vector quantity, right? Now, of the four equations of motion, okay, which one am I going to choose? Remember, I'm looking for initial velocity, so of course any equation that I choose must have initial velocity in it. But what do I not have? I don't have time. So of the four equations, there's only one without time. Okay, can you guess that one? Of course, it's the one that says Vf squared is equal to Vi squared plus 2a delta y. Okay, so I'm just going to move this a bit. Okay, delta y. So now let's substitute all that we know. So final velocity, we remember this guy is 0. So this is 0 squared. Our initial velocity is what we're looking for. Our acceleration, remember we said it's minus 9.8. And our displacement, I'm just going to move this a little bit. Okay, our displacement is simply going to be 20 meters. Okay, right, so it's positive 20 meters. So now what do I get? Right, if I bring this over to this side, okay, so I'm going to take the square root of, all right, 9.8 multiplied by 20. Okay, so I get a velocity. Okay, so now keep in mind, when you take the square root, so it means that Vi squared, okay, just to remind you, would be equal to, Vi squared would be 9.8 times 20. But if I want to take Vi, in this case, it would be the square root of, now remember, when you take this to the other side, it becomes positive, right? It would be negative here, but when you take it to the other side, it becomes positive. Just a very important thing to note is that whenever you wanted to take that square root and you found that you've got a negative number, it's actually in a way telling you that you might have done something wrong. So it's always good when you get the square root of a negative number here, it tells you that perhaps something went wrong either in your calculations or in your choice of values or in assigning or ascribing direction there. Okay, so I get a value of 14 meters per second. Now you need to be careful. Remember, when you take the square root in mathematics, you always say plus or minus, right? Now we need to make a choice here. Which one are we going to take, the plus or the minus? Remember, that tells us about direction. At A, in which direction was it moving? Remember, it was thrown vertically upwards, and we've said upwards is positive, so it means that our velocity, but either way, they said the magnitude. So in this case, the magnitude of our initial velocity would be 14 meters per second upwards. Okay, right. So now they say calculate the time that the ball is in free fall, right? So when is it in free fall? In this case, all the way from A up until C, it is in free fall. This is motion that is influenced by gravitational force only. So everywhere, between those 2 points, it's actually influenced by gravitational force. Now, I'm just going to bring this over to this side and continue on the other side. So what I'm going to do is, let me take information from A till C. So it means I'm taking from the moment it left, the ground, up until it reaches that maximum height. So I'm going to say, well, what is my initial velocity? So velocity at that position A, we just calculated it. We said it was 14 meters per second. What about our final velocity when it reaches C? Remember, we do not know that velocity, right? And then, but what about our gravitational acceleration? Remember, we said in this case it's going to be minus 9.8 meters per second squared. Okay, that's meters per second. And the time that it takes, that's what we're looking for, right? And we want to know what is our displacement. Right, now please, I want you to note, ladies and gents, when it left the ground, it left 20 meters, it went to maximum height, and it returned to this point at 13 meters, right? Now, I want you to please note, when we talk about displacement, we are simply saying this is the straight line change in position from the beginning to the end point. So in this case, remember, it was displaced 20 meters, another 7 or so meters downwards. So it would be 20 meters in the positive direction. It would be minus 7 meters in the negative direction, right, going downwards. Okay, so what would be the total displacement between A to C? It would be 13 meters in the positive direction. Think about it, it's 20 minus that 7. So in this case, it would be 13 meters in that direction. I hope that makes sense, ladies and gents. Okay, so it's a positive 13 meters. Now, we're looking for that time there. Okay, so you can actually use remember, we're looking for time. We don't have final velocity. Yeah, sure. I see I'm going to get that, that quadratic equation. So in this case, I can use the third equation, delta y, that's vi delta t, plus 1 over 2 times a delta t squared, right? But what is my value for delta y? We said this is going to be 13 meters. Okay, our initial velocity, that's going to be 14 meters multiplied by the time, plus 1 over 2a delta, our a value is 9.8. Sorry, I forgot to put that value there. So that's 9.8, but this is delta t squared. And I think someone asked me what happens when you get two values for time. I'm going to explain that in just a little while. So then we get 13 is equals to 14 delta t. Okay, that's minus there, sorry. You substitute that negative 9.8, then you get minus 4.9 delta t squared. Okay, right, so let's try and put it in as a quadratic equation. I'm going to take that to the other side. So 4.9 delta t squared minus 14 delta t, okay, plus 13. So remember, taking everything to the other side changes its sign. This is equal to 0. Now, ladies and gents, you can decide to use the quadratic formula, right? So remember, what does the quadratic formula say? So delta t, in this case, that's our subject of the formula, is going to be minus b plus minus the square root of b squared minus 4ac, okay, divided by 2a. So let's do that quickly. Our b value was minus 14, so that's minus a negative 14 plus minus the square root of, okay, our b squared, that's going to be minus 14. Please remember, ladies and gents, when you substitute that into the bracket, you must actually put it inside the brackets, right? Minus 14 squared, all squared, right? Minus 4, our a value is 4.9, and our c value is 13. Okay, right, so there we have it there, divided by 2 times 4.9. Of course, all that's left for us to do is to put that in the calculator. Right, I'm just going to adjust that a little bit so that you can see it. So that's multiplied by 13 there. All right, so that's let's find the values. Okay, let's get that value. Okay, when I calculate there, for some odd reason I keep getting an error. All right, I don't know what I did wrong there. Okay, but okay, this would be the approach, but we should get the correct answer. I think because we get a negative there, you know, the square root of a negative number obviously would obviously be undefined. Okay, yeah, but theoretically I should be getting a value. All right, look, I'm not going to waste any more time, so you know what to do here. Okay, you would be able to get that time. Let me just show you how you would have tackled this alternatively. If you guys are able to, please just help me out and tell me. You can just comment there and tell me what I did wrong, if there is anything that I did wrong. Okay, but alternatively, what I could have done is to calculate. Now remember, already I worked with that information from A to B, so I could have calculated the time that it takes from A to B. I already had the information. I could have used the first equation of motion. Okay, so I could have said this is Vf is equals to Vi plus A delta t. So my final velocity is 0. This is between A to B. My initial velocity was 14 plus, in this case, a negative 9.8 delta t. So we would find that time there. So you take the 14 to the other side, it becomes minus 14 is equal to minus 9.8 delta t, right? So that would be 14 divided by 9.8, and you would get 1.42. So it means that the time from A to B will be 1.43 seconds. Okay, I'm just going to round it off there. And then I can find the time between B and C. Okay, so from B to C, I want you to please note my initial velocity would be 0. Okay, I don't know what my final velocity is, but I do know, in this case, the displacement. I do know gravitational acceleration. Of course, again, it's 9.8, negative 9.8, right? Still going downwards. I would also know the displacement between B and C, and in that case, that would be so which equation of motion? I'd be looking for time, and I don't have final velocity, so I can actually use this equation. So I'd say delta y would be Vi delta t plus 1 over 2a delta t squared. So in this case, remember my displacement going downwards would be minus 7. So remember, as it was going down, it's displaced from B to C, negative 7. My initial velocity in this case would be 0, okay, from B to C. So that would be 0 there. And that would be plus a half of minus 9.8, and I'm looking for t squared. So all that we simply do, Okay, so divide both sides. A half of 9.8 would be 4.9. So you know how the cookie crumbles, right? So 7 divided by 4.9, and in this case I just simply take the square root of our answer, and I get an answer of okay, I don't know if this would be correct. So we said 7 divided by 4.9. Okay, and we get an answer there, and we said we take the square root of that answer and we get a value. All right, so I seem to get a time value of 1.1. Okay, I'd say 1.2. Okay, rounding it off, that would be 1.2 seconds. So that would mean the total time of flight. And as I said, please just check this one for me. Okay, of course, I'm sure that you understood it. Okay, so my total time of flight would be that 1.2 seconds plus that 1.43 seconds when it was actually on its way up. So the total time of flight should be 2.63 seconds. All right, so that is the time that I get there. Okay, that is how I would have tackled that question. All right, so the very last question, they say calculate the kinetic energy of the ball when it hits the roof of the building. So what do I need there? It means I need to find the final velocity at this point here. So because I've already in a way kind of worked with B and C, let me find, if you don't mind, I'm going to try and squeeze it over there. Okay, so I will find that final velocity and I'll say, well, I'm looking for the final velocity. I've got the initial velocity, I've got the acceleration, and I also have the time, right? So I'll say, so VF would be VI rather plus A delta T. So I'm looking for that final velocity. My initial velocity from B is 0. My acceleration is minus 9.8. Remember, it is still going downwards, right? Multiplied by that time. And, of course, I've rounded it off. That would be 1.2 seconds. And so what would be the value? That would be 9.8 multiplied by 1. Okay, I still have it in my calculator without it being rounded off. So I'm just going to say multiplied by 9.8 and negative 9.8. And I get that value to be minus 11.71. Okay, so that's my velocity. Why am I getting it as a negative? Why am I getting a negative? Obviously because it's going downwards, right? So we chose up as positive, so it's telling me that it is going downwards. But remember, they were looking for kinetic energy, so we say this is half mv squared. Okay, so that's half. My mass is 600 grams. So remember, in physics we always work with kilograms. So this is going to be 600 divided by 1,000. So that would give me 0.6. That's how you convert from grams to kilograms. Okay, multiplied by that velocity there. And by the way, just the magnitude of it should be sufficient. Okay, you can substitute it as negative. It's fine. That's negative 11.71. But please remember to square the negative as well. Okay. And in this case, what do we get? We get, so let me just square that number, multiplied by 0.5 times 0.6, and we get a value of 41.16. So that would be my kinetic energy. All right. So that would be the kinetic energy of the ball as it lands on the roof of the house. Right, so I hope that makes sense. By the way, please just make sure that you try and verify this for me. You should get, in fact, theoretically, in my thinking, we should be able to get two values for time there. We'll get a time when it actually passes that point there, and we'll get another time when it actually lands on the roof. So please just try and verify that for me, and see if you can get that answer using the quadratic formula. But I'm sure you got the gist of it. Okay, right. Alternatively, what you can do is just find that the different times on its way up and its way down, and that's what I is eventually resorted to. Okay, so I hope that you understood that. All right, and hopefully for those of you who wrote this paper in Mpumalanga, you did quite well on it. Okay, so please don't forget to subscribe, and I'll see you guys next time. Sharp, sharp.